Hey everyone, it's Molly. Sorry I can't see you all today, but I wanted to create a sort of, hopefully small video walking you through the problems on the test, okay? Keeping in mind that this test was password protected for a reason, and I would appreciate it if you did not record this video or share it out. I mean, we're changing the test next year to new questions, so it doesn't really help anyone, and it kind of wastes time. So use your time wisely in class, and don't worry about anything but getting these corrections done. So what I want you to do is follow along with me as we work and make corrections. If you're already good, if you've done this problem right and you didn't lose any points, you can just skip ahead in the video. If Elizabeth or Maria are showing you this video on the screen, you can just sort of follow along or work ahead. And this video is to help you kind of grasp what errors were made and what I was looking for on the test. When you're done at the end of class today, I need you to take a picture of the first page of your test and put it in Canvas in the section I put in your OneNote, okay? And that all those details are in the email I sent you this morning. So, first question, what factors determine the speed of a sound wave? So there were two very key answers here, and I gave a little bit of wiggle room in terms of what you were saying, but you need to know the temperature of the medium you're dealing with. Oop, I can already not spell. You all knew that already. And you need to know the medium itself. Remember, the closer together the molecules are in the medium, the faster the sound wave travels. So, for instance, water, or the speed of sound in water, is greater than the speed of sound in air because the water molecules are closer together, so it takes them a little less time to travel to the next molecule to hit them, okay? So the two things we were looking for were temperature and medium. Okay, so explain in one sentence how or why visible light reaches the surface of the Earth. On this one, this was a lot like that question I asked about why ultraviolet light doesn't reach the Earth. Okay, all I was looking for was something along the lines of visible light transmits through the atmosphere and is not absorbed or reflected. And as long as you said it transmits to the atmosphere, I think I gave you full credit. So the answer here was that visible light transmits through the atmosphere. Okay, simple, or I think I gave full credit, or is not reflected or absorbed, because the only other option was transmitted. Okay, I really wanted you to be able to use those words that I told you to get comfortable with: transmit, reflect, and absorb. And especially now that we're in our color unit, these terms are not going away. So how does the energy of a wave change as the wave's frequency increases? Okay, so energy is equal to h times the frequency, or h bar c over the wavelength, okay? So if I increase the frequency, and this is a constant, if h bar is a constant, then the energy also has to increase as well. So it's just, the answer was just it increases. And you did not have to write out the formulas I did. Calculate the speed of a wave with a frequency of 678 megahertz and a wavelength of 0.112 meters. So you've already seen how I approach problems. I always underline what I'm being given and what I know and what I'm asking for. So you didn't need to do a problem solving format here, but you do need to use that wonderful formula that we always use, is that the speed of any wave is equal to the wavelength times the frequency. Now, a couple of things you had to do here though. The wavelength was good, it was in the right units, but 678 megahertz is the same thing as 678 times 10 to the 6th hertz, okay? Because mega is 10 to the 6th. That was one of the prefixes we learned, okay? So what you want to do here is, the simplest way is to move the decimal over and call this 6.78 times 10 to the, since I moved it 2, I'm going to add 2 to the 6th, and I'm going to get 10 to the 8 hertz, okay? So the speed of this wave is 0.112 meters times 6.78 times 10 to the 8 hertz. Quick sig fig check while I stall to grab my answer key. 0.112 has 3 sig figs, so does 6.78. So you're in a very clear situation here where you just need 3 significant figures. And the answer to this at the end of the day was 7.59 with rounding times 10 to the 7th meters per second. And I was looking for you to have the sig figs, the rounding, and the units here. Okay? You did also have to show your work. That was important. So, calculate the energy of a wave with a wavelength of 656 nanometers. So, a similar thing where we have a prefix involved, 656 nanometers is 656 times 10 to the negative 9 meters. And we could do that same trick before. We could say this is 6.56. So now I'm adding 2 to negative 9. So I get 10 to the minus 7 meters. So that's the number I'll ultimately plug in. But I got to use the formula. So I know that the energy of a wave is h bar f or h bar c over lambda. Looks like I've been given the wavelength, so I need to use this formula right here. So I'm going to say that the energy is equal to, I'm going to plug in all my numbers. I'm going to plug in 6.63 times 10 to the minus 34 joule seconds. I'm going to multiply that by C, which is 3.00 or 2.998. Doesn't matter. Actually, I'll use 2.998 because that's what I did in the key. 2.998 times 10 to the 8 meters per second. Okay. I'm going to divide that by the wavelength, which is 6.56 times 10 to the minus 7 meters. And then I'm going to get, once all the rounding and everything shakes out, 3.03 times 10 to the minus 19 joules. Okay? That's the answer. Okay, this one, most of you all got this one. Why do we skip even harmonics for a tube with one closed end? And remember, that's because the even harmonics have nodes at the end. At the open end, specifically. And remember, specifically, what that means is that if you have a node at the open end, that creates no sound. Okay, and remember, keep in mind, that is the worst whistle ever designed, if that's the one you design. So the even harmonic have nodes at the open end. Some of you didn't quite use the right vocabulary, but you drew good pictures, so I think I give you credit. Oh, and just for the record, if you all want to ask clarifying questions about how I graded, or you're not sure exactly what you did wrong, feel free to ask. Like, if you think I did something wrong, just bring it up. It's entirely possible I did, and I won't fault you for asking. Give me a second, I'm going to drink some more coffee. Okay, so you see lightning well before you hear the thunder from lightning. Why? Almost everybody got this right, and that's just because light travels faster than sound. Right? That makes sense. Okay, so the last one was a dimensional analysis problem. So if you did not set this up in the proper dimensional analysis format, you would have lost points. Some of you got the right answer, but with the wrong format, and you still didn't get full credit. Remember, I specified the dimensional analysis is a skill I need you to pick up. It's not because I don't think you can do it right. It's because you're going to need to do this a lot in your next in chemistry, and I need you to be able to get comfortable with it here. So for 33 minutes, I need to convert 33 minutes to years. Okay, and so what I'm going to do is I'm just going to set this up with all the conversion factors, making sure that the units I start with are the ones on the bottom, and the units I want to go to are the ones on the top. So I'm going from minutes to hours. Next up is hours to days. That makes sense. And then after days, it's 1 year. You can use, remember, we just used 365. It's totally fine. Even though it's technically incorrect, you got a little bit of, it's like 365.25. Bearing in mind here at the beginning, we have 2 sig figs in our 33, and that the sig figs in our conversion factors don't factor in. Remember, we treat those as exact. So we only have 2 sig figs at the end, so the end game here is 6.3 times 10 to the minus 5 years. Now, you might be plugging numbers in as I go on your calculator, and you might still not be getting the right answer, and that is a calculator error. That is frequently something I see here. Calculator errors abound up at the top, okay? So if you're wondering about that, ask me in class the next time we're in class together, and I'll show you how to plug it in your calculator. The trick is using parentheses around exponents. So if I were putting this in my calculator, I would put parentheses around everything, because my calculator isn't quite as smart as I'd like it to be. So for those of you who I rushed off on number 8, sorry about that. I came back to it while you finish up your writing. The next one was just practicing sig figs in units to get you kind of primed. So a couple of things here. a lot of you did pretty well with the first one. The second one gave a lot of people a lot of trouble. So let me just write this out here. When you multiply 0.00109, that has 3 significant figures. 10.64 has 4 significant figures. So when you multiply all these together, you get an answer that will need 3 significant figures. So you're going to get 1.16 times 10 to the minus 2. And it's okay if you wrote 0.0116. I don't mind. But a lot of you all messed up on the units, okay? When you multiply meters times meters, you get meters squared, okay? They don't go away. They don't disappear. You square the units together as well. The second one was harder because I gave you basically a length unit over a length unit. Okay, let's do a sig fig check here. We've got 0.24567.00. I'll admit this one was tricky, but this 0 out here is irrelevant. But 24567.00, those are all significant. So that is 7 sig figs. Trickier thing, 0.0009 has 1 sig fig. So ultimately your answer has to have 1 significant figure. You're going to get something along the lines of 298 at the end of this, but you got to do some conversions here, okay? You can't just divide these numbers straight because centimeters and kilometers are not the same. So what you need to do is you need to do 24567.00 centimeters, and then you need to convert it to meters. So you need to divide it by 100. You need to do a similar approach to 0.0009 kilometers. You need to do that. You need to get that into meters, and that is 1,000 meters in 1 kilometer. Okay, so then these numbers become something different. You get 245.6700 meters when you divide this by 100. When you do 0.009 times 1,000, your decimal place moves over by 3, so this becomes 0.9 meters. Okay, so what happens is if you divide 240, now we can divide them cleanly because they're both in meters. So you get 245.6700 meters divided by 0.9 meters. And you get something, you'll have to plug these into your calculator because I only have the rounded number in my key. But what this gets to is when you round this to 1 significant figure, remember we have 7 sig figs and 1 sig fig, you get 300. Here's the trickiest part. The meters go away. There are no units. This is just a scale factor, okay? It's like saying something is 2 to 1. That 2 and that 1 do not have units on them. I'm just saying the ratio is 2 to 1. That 300 is a number without units. That tripped up a lot of people, so I want you to be careful about writing this one out. Okay, so the next one, and remember, if you're watching this on your own, you can just pause it whenever. And if you're not, you can always ask Elizabeth to pause it. Don't be shy. Or Maria, sorry. I have a couple of subs this week. So we determined the speed of sound experimentally to be 342 meters per second, and the theoretical was determined to be 343.9. So determine the sig figs in the following % error. Now, upon rereading this, I think this looked a little tricky, and I might rewrite this next year. So I accepted 2 approaches to this problem. Technically, that 342.42048, this number right here, because I gave it to you in the problem as 342, it really should be significant to the 1 place, but it was tricky to explain this because what I did is I gave you the unrounded value, but I wanted you to know that it was only 342. But I get that was kind of ambiguous in given in the problem, so I kind of took it 2 ways. I accepted 2 answers for this. The 343.9 was fine. It was clean. It didn't have a big conflict in terms of the values. But what tripped a lot of people up here was I think maybe it was a strap for time thing, but there were 2 significant figure steps approaches to this problem. First of all, I gave you the actual answer, so that's great. You don't have to do that crazy work, but you do want to track your sig figs. So the first thing you do is addition and subtraction, which means you have to do 342.4208 meters per second minus 343.9 meters per second with your absolute values in play. And you get 1.4795. Okay, now this is where I have to factor in the 2 approaches. Based on the way the problem's worded, the 342.4208 is significant to the 1's place. and the 343.9 is significant to the 10th place. However, I accepted 2 approaches. If you marked it significant to the ones, that was great. I also accepted if you marked it to the 10th place.